Ladies and gentlemen, a lot has been imagined, recreated, innovated in the automation space to take all your learnings to the next level of automation. We have someone who heads the open source test automation practice in Tech Mahindra. He comes with 17 years of rich IT experience, and in that 8 years specializing in testing and test automation. He has vast experience in implementing test automation in diverse testing projects across verticals and geographies. He currently focuses on bringing AI-based solutions to common testing problems. With a big round of applause, may I invite Principal Consultant Tech Mahindra, Mr. Dinesh Velhal, to present on intelligent test automation. There is a change in the topic. The topic mentioned is open source tools in testing world. Mr. Dinesh Velhal to present on intelligent test automation. With a big round of applause, ladies and gentlemen.
Thanks. So, hi everybody. I hope you are refreshed after having tea or coffee. My topic is intelligent test automation, and you can also see its test life cycle automation. So, when we generally talk about test automation, we normally think about test execution automation, a very specific testing activity. This session is not only about the test execution automation, but anything and everything about testing that we can automate using some intelligent techniques, mainly the AI and machine learning based techniques. So, how many of you here are from testing delivery background? Any of you working on test management or managing the testing projects? Can you please raise hands? So many of them. So, where does test lifecycle start? So, what is the starting point for the test? When we say test lifecycle, what is the starting point for the test lifecycle? The requirement analysis stage, right? But practically, I think you can agree with me that the test manager's problems start much before that. So, for example, now when you get a new project and you're setting up a team and you are setting up a new testing project for a new customer, the first challenge that you face is the resources. So, how many of you are really happy with the way the resources, you get the resources, are they really as your expectations? For example, if you're looking for say 2 or 3 Selenium resources, do you really get good profiles? Right, so you have to go through lots of profiles, sort through them, filter and really find out a right profile. Why this happens is because you as a testing team person, you prepare a job description, you know what you want, okay, now you share that profile with a resource management group, someone who provides you the resources. Now they are typically non-technical people. They have lots of CVs shared, stored on their hard drive. Okay, what they do, you want a Selenium resource, find in files and Selenium as a keyword, and whatever CVs you get, all of them they are shared with you, right? That is mostly what happens. What happens is in many cases, even if those CVs which have written like attended Selenium training in 2009, even that CV reaches you, right? Of course, I think it's a day-to-day problem for every testing. So, some earlier presenters mentioned about machine learning. Okay, so machine learning techniques can surely solve these kind of problems. Okay, so they can solve your problems even before your project starts. There are some techniques called as natural language processing techniques. Combined with the machine learning algorithms, you can actually have a agent, a virtual agent or an assistant running on your machine, or you can keep it as a server running inside your organization, which can find out a right CV as per your job description. So I think that is one example where you can apply intelligent test automation. It's not exactly testing activity, but it is related to testing, and you can surely automate it. Another thing is, there could be some pre-sales professionals here, right? So when you receive a new RFP document, okay, and you have to respond to it, you have to submit a proposal to a customer, okay. What you typically do, normally those RFP documents are like 50 pages, 60 pages, or sometimes even 100 pages RFP documents. You spend, like a group of people from different testing backgrounds, they sit together, scan through it, read each and every line, trying to interpret what is expected out of it, and then you work on the proposal. Just imagine a computer assisting you to find out the summaries of your proposal documents, okay, rather than everyone reading all your proposal documents in detail and spending around 3 to 4 days or even week to understand what is expected. You get a gist out of your document, and you just need to go through that summary, a topic that is extracted for you, okay, and then that saves your time. Now again, this activity starts much before you actually start doing testing. So your automation can actually start much before your project begins. These are a couple of use cases I would like to mention, and then now we start with our presentation. Yeah, so our agenda is, okay, so I'm going to focus on the applications of machine learning techniques to testing applications. I'm going to spend a few minutes on what is machine learning in layman's terms, no jargon, no technical terminology to be used. So please bear with me. I might be technically incorrect in some cases, but I just want to keep the topic easy to understand. Okay, so after that, we will see what all possible testing use cases where we can apply the machine learning techniques and get benefited out of it. Peter earlier mentioned in his session that they already have implemented machine learning techniques and they are benefiting from it. Okay, so so there are examples where people are really benefiting from it, and probably if you have not started working on it, you can surely consider the idea of using machine learning techniques. We will also take a deeper look at one testing use case where we can apply predictive analytics, specific machine learning technique for predictive analytics, and how it can benefit you take early decisions. Okay, so taking decision is important, but taking timely decisions is even more important, especially when your testing projects are complex with lots of applications in scope, diverse teams spread across multiple locations. It makes the job of test manager very difficult. Some techniques that can help the test manager take early and correct decisions. I think that is what machine learning is. So we will take a deeper look at one use case. And next interesting topic will be the conclusion. Okay, so I'm not going to draw any conclusions here. Machine learning is still new. Applications of machine learning to testing problems is even newer. Not lots of people or lots of projects are using machine learning techniques. So we are still learning about machine learning, I would say. In fact, I myself started learning about machine learning techniques about a year ago, and I'm exploring it. There are new findings every day. Even the world is taking up, there are new applications coming up every day, like Facebook and Google. They're using these techniques a lot. Okay, so I'm not going to really draw any conclusion. I'll share my opinions, and I'll invite you to also share your opinions about it. So there will be some open questions that we'll together try to answer and form some ideas and reach towards forming some conclusion about machine learning techniques for testing. Okay, so a quick introduction about machine learning. Okay, so a typical programming concept, how it works. When someone writes a program, okay, how a traditional programming approach works. Okay, you write a program, your program uses some data, okay, and your computer executes the program by using that data, and you get a desired output. So that is a traditional programming approach. Now, when it comes to machine learning, there is a shift of paradigm. You have to change your understanding of how things work. This is not how it works when it comes to machine learning. You have to shuffle those things a bit. Okay, so in case of machine learning, you already have data with you. You already know what is the output. Okay. Your computer, by making use of machine learning algorithms, make sense out of the data, make sense out of the desired output, and it actually forms your, it actually gives you a program as output. Okay. By program, what we mean is a trained algorithm that can solve your problem for which you are trying to apply your machine learning technique. Okay. Just see the difference between these two. Once you understand this, I think machine learning, the gist of machine learning is this. Okay. Again, I am not fully technically correct here. This is not everything about machine learning. This is about a specific technique of machine learning called supervised learning. In case of unsupervised learning, the output is missing. You don't feed the output to your program, you only feed the data. Computer finds out the patterns, makes sense out of the data, and give you a desired trained machine learning algorithm that can solve your problems. Okay. But I have not put that here to keep the thing simple. Yeah, so I just talked about supervised machine learning and unsupervised machine learning. Okay, there is another type of machine learning technique called as reinforcement learning. We'll mainly focus on supervised learning because I personally believe, based on my experience, that if you apply supervised learning techniques, I think that is more than sufficient to really try to tackle your testing related problems to begin with at least. Okay, so there are techniques for regression, classification. Now regression, please, this regression is not about the regression testing. Regression is a predictive analytics method which is about predicting a continuous output or a continuous result. Okay, for example, if you want to predict the number of defects that you might receive in a typical release for a specific requirement, a specific testing requirement. The number of defects is a continuous value. I mean, it can be from 0 to 100, or it's a continuous output basically. So the technique for predicting the continuous values is called as regression. While predicting a discrete output, like predicting a success or failure of a requirement, okay, predicting whether an incoming mail is a spam or not a spam. Okay, so you are basically categorizing your data fields or data values into categories. Okay, that is called as classification, supervised learning techniques. Unsupervised learning is where you actually don't know what is the output. You only have your data points, the historical data, and your algorithm tries to find the patterns out of the data and try to categorize the data without really knowing what that category is all about. We'll not go in too much of a detail about supervised learning. We'll mainly focus on we'll not focus much on unsupervised learning. Our focus will be mainly about supervised learning. And then reinforcement learning, I'll just mention what it is and then we'll go ahead. Basically, it's about an algorithm which trains itself by experience. Okay, so it tries to take a specific logical path. If there are obstacles or if there are specific conditions not met, it will try to take another path, and by doing this, it will try to form a bigger picture about the entire data set. So that is reinforcement learning. Again, I am not going into detail about that. One more important topic is NLP, the natural language processing. Now, this is a very important topic for the testing applications. Lots of testing data that we have or we keep on creating on daily basis in our testing projects. We have requirements documents, we have requirement definitions, test cases, test scenarios. When we raise defects, it has lots of textual data that is generated by a human tester. So lots of English, human language related data is getting created on daily basis. So NLP techniques is very important for applying ML techniques to your testing problems, because data is mainly textual and is mainly written using the human languages. The data is created by humans, the testers. Okay, so let's see what is the supervised learning. Again, these are technical terms, but just pay a little bit attention. It's a very fairly simple concept to understand. So, supervised learning and a classification technique. I have just taken a simple example. You have data points available for different species of flowers. Okay. Now these data points have 4 fields: the sepal length, sepal width, petal length, and petal width. Okay. Petal, you know, I mean the petals of the flowers. The sepal is the green part just below your petals. Okay. The green leaves that are there which protect the flower when it is it is not yet bloomed. Okay. So that those greener parts of your flower is called sepal. So there are data points available, the width and length of sepal and the petal, and you already know the categories for those data points. So if you already have a categorized data, a sample available, okay, so that category is called label. Okay, again this is a technical term used commonly in machine learning. The output is labels. Okay, it's called labels, and these are your input data points. Those are called as features. So you have your features and you have your labels. When you have both of them, okay, your predictive analytics technique is basically a supervised learning technique, because you already have the output. Okay, so there are sufficient data points available where you know the features and you know the output or the type or classification already done for you. Okay, and then you feed this data to your machine learning algorithm. It makes sense of the data and trains the model or trains the algorithm. Now once the model is trained, and if it is trained correctly, you can then feed the new data points where features are available, but you don't know what is the classification. Okay, and then your program can actually do the classification for you. And for this example, you can surely achieve the classification success rate of about 98 to 99%. Okay, so the machine learning algorithm can correctly predict the type of flower based on the new data points. Okay, now this, it's a very simple example. There are only 4 features, but in real life, in real practical problems, testing, or there are many other problems, the number of features could be in thousands or even more than that. Okay, so for a human, it's very difficult to understand and find out the patterns out of the data. The algorithms can do that very quickly and very efficiently. Now this technique where you have the features as well as the labels is called supervised learning technique. Unsupervised learning is again simple. The only difference is you have the features, but you don't know the category to which those features belong to. So you only know these data points, but you don't know whether what type of flower that is. Okay. Here, the job of the machine learning algorithm is to basically classify or cluster the data points into different groups like this. So you don't know what that cluster is called. Okay, but the grouping is already done for you. Now when you get a new data point, okay, the algorithm can predict whether the new data point falls into this cluster or into that cluster. Okay, without really knowing the name or the type of the category. So you don't provide the categorization information to your algorithm. Okay, so that is called as unsupervised learning. I'm just want to go back to a previous slide. In case of the supervised learning or the classification part, when you all have the labels available for your learning data, okay, the classification algorithm, what it does is rather than grouping the data points together, it actually forms a boundary between those data points. So any new data point that you receive and you want to make a prediction, if that point falls above the line, then it's a versicolor species of the flower. Okay, as you see here, all the blue points are above the line. So you can make a prediction. So this is classification, while the other case that we saw, that is unsupervised learning, is clustering. This one. Yeah, so that is about supervised and unsupervised learning. There are so many new things to it. there are so many things that I have not covered, but this session we really cannot cover all things about machine learning techniques and types. So what could be the testing specific use cases? Okay. In testing, okay, I mean in any testing project, you have lots of data available. Every release you create new data. You have your test cases, you have your defects, test case results, right? So I have identified a few use cases where you can effectively and efficiently apply the classification or regression techniques of machine learning. Okay, we already saw just 2 case studies earlier. An efficient sorting of your user profiles or CVs, or making sense out of your RFP document that you receive. So these are 2 use cases. For sure you can apply the machine learning techniques, predict the number of defects. Now this prediction, probably if you have worked on smaller testing projects, this might not make sense to you, because testing projects with 5 to 10 people, probably the test manager based on his experience can make those predictions, and with the gut feeling and the past experience, people actually can form some intuitive idea about how that release will go on. Okay, so you really don't need to make those predictions in small testing projects, because you can do that yourself. Okay, you don't need algorithms for you to tell that to you. But consider complex projects where, and I have seen projects where more than 400 testers work together as part of a testing team and they test multiple applications from different programs from the customer side. Again, at that point, when you actually test hundreds of new requirements every release, predicting the number of defects and accordingly prioritizing your testing areas or test cases can definitely help. Predicting if failed test case means a new defect. Okay, when you run your automated test cases and lots of test cases, if your automation is really good, probably you are running unattended nightly batches every day. Okay, now whenever there is a failure, is your automation framework really in a position to decide whether it's a new defect when a test case fails? Can your framework know if it's a new defect, or it's a already existing defect, so you don't have to raise a new defect, or it's something like an environment problem, like application is down? Okay, so in most of the cases I have seen, the automation tools can raise a flag, a red flag, that something is wrong. But what exactly is wrong, and basically taking the action based on the failure cause, is something that we really don't see in real life. Because the main focus of the automation tools is execute the test case, find the results and either tag it as failed or passed. But the root cause analysis is something which is very difficult to do. Probably the machine learning can help you there if you complement your test automation with some of the machine learning techniques. You can scan through all these use cases. There are many, and probably you might have some more use cases in your mind. Okay, this is not the whole thing. There could be many other use cases. Okay, so yeah, so we will take a quick look at a specific use case, and then how to approach your machine learning, how to really approach the problem of applying the technique to your data. Okay, so you want to predict the likelihood of success or failure for a new requirement. Okay, so in a typical release, if you are receiving more than 100 new requirements to test, of course it is going to help you if you can have some idea about what requirement will require more attention. Okay, accordingly you can prioritize how the resourcing is done. You can put more resources to work on those critical requirements. Okay, so these are the benefits of, like, basically why do you want to predict the likelihood of success or failure. Okay, so now understanding that yes, it's a valid problem for a complex testing project, let's see how we want to go ahead and what all steps you need to take. Okay, so these are the 2 categories, or these are the 2 classes that you want to predict for all the new requirements that are coming up. Okay. So in your testing life cycle, all these testing phases are there. What all data point that you can use to make these predictions? Okay. One sure data point that you can have is at the point where your requirements are available. So you can find out multiple features about your requirement, like the requirement is about which product, the designer who has worked on that requirement, when that requirement came into your scope of testing. Okay, the later the requirement is available for testing, the less time you get for testing. Okay, and then there is more risk of that requirement getting failed. When we say failed, either it gets deferred or it gets blocked for some other reason. Okay. So you can have some lots of relevant data points from the requirement itself. Okay, those data points you can make use of. Those data points you can feed to your algorithm, and your algorithm can get trained to make the predictions. Another data point will be when you actually write your test cases. Again, those test cases can be your data point. So you have lots of historical data about your previous releases. Okay. All the data about your requirements or test cases can be the input to your machine learning algorithm to get trend and then start making the predictions. So some of the fields I have mentioned there. So I'll just take a pause. Does it really make sense to you? Do you really think that machine learning can really help you? Is there any problem that you think that you have that machine learning can really solve for you? Yes, right. So there is a specific machine learning technique called as anomaly detection. Mahesh also talked about that. So I know there are machine learning algorithms that you can use to find the outliers. Okay. So those algorithms, what they do is they find the patterns in the historical data that you have. Okay. And then it can also detect the data points which lie outside those patterns. Okay, either above or below the patterns. So those are typically the anomalies. Now those anomalies, they typically are detected based on what features or what fields of your data points you are making use of. Okay, if you use correct data points or correct features for making those predictions about the anomaly detection, then yes, those outliers you can find out. Okay, so for example, you have lots of data available as a output of your automation runs, okay, and hundreds of test cases that you are executing every day. Okay, all that data for a human, it's typically very difficult to find those outliers because it's numerical data mainly or textual data. You cannot find it out in a given time. Okay, so those algorithms can really sort through thousands of data points, find out those anomalies. Those are called anomalies or outliers, and then you can focus on analyzing those anomalies and then make it as part of your learning algorithm so that those anomalies vanish in the next iteration. So this is a typical process that these are the steps that you take when you start implementing machine learning in any project, not just testing, but for predicting anything in any uh, uh, any prediction problem. Okay, so you collect the data, you prepare that data. When you now these two steps, they involve lots of steps. It's a iterative process. Mahesh also mentioned that machine learning, the algorithms part is very simple actually. Okay, you can learn those, lots of tutorials are available. But this process is iterative. You really know your data. That is the main need. You have to have correct data, you have to have the relevant data, and you really need to have sufficient data. Only then your algorithms are going to work. So this initial first 2 points, they are very important. Rest of them, they are also iterative, but they are, I would say, easier part of your machine learning problem. Okay, so due to the lack of time, I'll just quickly move ahead on this slide. And I think this is going to be the important point. Okay, now machine learning is fairly new. We are still learning about it, and I myself, I would say there are few areas of testing where I'm not sure whether we can apply the machine learning or not. Okay, it all depends on what kind of data you have. Okay, and data availability varies from project to project. So. I'm not going to draw any conclusion, but do you really think, are we in a position to conclude about whether machine learning is really useful for testing? Any ideas? I would say it's still evolving. There are few problems that I have tackled. I know it is very useful for specific focus problems, but as a whole, do you think it is useful? Let's actually take few specific questions. Okay. Machine learning sounds very time consuming. You have to collect lots of data. You have to clean that data. You have to filter the data. Lots of steps are involved. You have to deploy new additional people to really take up machine learning. Is it really worth it? Any ideas? Any inputs? Anyone has anyone used machine learning anywhere in the testing projects?
Based on that, we get the ad choices. So everything is machine learning today, and I mean we can't do away without it, right? So
Right.
it is the in thing.
Exactly.
And of course, being into testing, so when there is something in right now, testing, of course, it has to be related to it. So we have to.
Right, right, exactly.
One more thing is with machine learning, basically you also have this, the machine is also self-learning, right? So as a result of it, I mean, with your automation, regular automation, you have to do a lot of maintenance on that. But with self-learning, the machine is automatically doing the maintenance. So maybe the initial effort will be much higher. But I mean, it can be used for a much longer term than your regular automation test suite. So I mean, the ROI over a long term, which will be much more.
Exactly.
Than automation.
Yeah, yeah. In fact, I'll give one example. Uh, we ran some small proof of concepts. Okay, so there are some huge testing projects where it's a test factory setup where uh, around 400 testers work together as part of the testing program. So it's a big floor space. All of them are co-located. Okay, and they work together and they test the applications in agile environment, and more than 100 applications are getting tested continuously. Now, what happens is, again, as I told you, every release you have to really analyze more than 100 new requirements, write new test cases, test them, and this all happens in Agile with, there is always time pressure, you know, right? We have seen that the use case that we just saw, predicting the likelihood of success or failure of a new requirement, we have seen 70 to 80% accuracy of prediction by the machine learning algorithm. And now with this, this was with the whatever data that was available and some filtering and cleanup of the data. If the data quality is high, I would say you can achieve more than 90% accuracy in predicting the new requirement. And this is very important because if you know the requirements which are critical and likely to fail, you can really prioritize your work and take a risk-based approach, deploy more resources or relevant or correct resources to tackle those requirements. So that is one use case that I have seen. So yeah, these questions, most of the questions answer is yes, you can apply the machine learning techniques. Yeah, so another point is available testing data relevant and sufficient to really make use of machine learning? So how much data is really required for machine learning? Okay, and is it really a correct data that is available? So any ideas, guys? Yeah, right.
So limited test data wouldn't make sense to make intelligent decisions out of it. So we definitely need more test data.
Right. So in general, again, my experience, and if you see articles about machine learning, the more the data available, the better. Okay, your machine learning algorithm can make better predictions. Okay, so in general, what it is said that if you have lots and lots of data available, if there is no limit on data availability, all the different machine learning algorithms, they perform equally well. Okay, so with less amount of data, some algorithms have better accuracy, while some other algorithms will have less accuracy. But that difference will vanish if you have lots and lots of data. So data plays a key role. You need to have relevant test data, you need to have correct test data. Okay, so choosing the right data is very important. Okay, and this activity is very, very project specific. Okay, for your project, you need to know what data is relevant for you, and then are you really capturing that data? Okay, probably in some cases, what happens is there are small testing teams. A definition of a complex test case might differ from team to team. Okay, and then if you have data with different definitions of your data, then making predictions or the effectiveness of predictions might go down. So you have to also do lots of standardization of data. So all the testing data set that you have, you should have same meaning of the same types of data. So when you define complexity, it needs to carry the same meaning across all testing teams. High complexity test case might mean 4 hours for one testing team, it might mean 2 hours for another testing team. If that is the case, you have to really bring them up to a same scale of measurement. Okay. So all these things actually go into that. Sorry. Just couple of more questions. The production data. Yes, some part of input data requirements can come from production data also, because there is no limit on production data. You can have lots of data, but to make predictions about testing success or failure for a specific requirement, you also need testing data. Like in the past, what kind of requirements have successfully delivered, or what types of requirements actually failed. You also need data about testers. Okay, a tester with 10 years of experience, but only 4 months of experience in the current project, doesn't necessarily mean that he is better than another tester with only 4 years of total experience, but 2 years in the current project. Okay, the other person probably will have better test cases written, right? So you have to really again then know your data, know your testing team. All that data really goes into making the prediction. So production data, some part of your input data might come from production, but majority of your testing data comes from the data that is generated by your testing team. We have 5 minutes. Okay, so another important point. Now, if you successfully deploy machine learning technique in a particular testing project, okay, and you are getting good benefits out of it, can the same thing, you can take it as it is and apply it in another testing project? Is it reusable? And whatever work you have done for one project, can it be taken as it is to another project, and can you save time there? All these questions are for forming some conclusions. Okay, so my experience is it's a very project specific requirement. The data that you need to make predictions and the data that you are really capturing as part of your test management, that is very specific to your project. So whatever you build on top of that to make predictions probably will need some tweaking when you apply the same thing into another project, because the other project might have different dynamics, different requirements, different testing problems, I would say, different domain or different types of functionality that you are going to test, different types of testing. Okay. So you can take an overall process and reuse it into another project, but the data points you really cannot reuse, because otherwise your predictions will not be relevant for your project. How accurate will be predictions? Again, I'll just answer that question. The predictions will be as accurate as your data that you fed to your machine learning algorithm. If your data is correct, clean and sufficient, then yes, you can get very good predictions out of it. So data is the main thing here. All other things play secondary role. Your data needs to be really correct and relevant for solving your prediction problem. What size and types of testing projects can benefit from machine learning? I already mentioned that for small projects, I think the test manager himself can really solve all these problems. You really don't need the elaborate techniques for doing that. But when it comes to a complex testing project with huge testing team size, if teams are geographically disconnected, they are working from different locations. Basically, if there is complexity that is beyond a human intelligence to make predictions, then you can apply machine learning techniques. There are no specific guidelines for specific, but then you can intuitively know where to apply the techniques. But in general, you you can no need to apply techniques for smaller testing projects with straightforward testing requirements. I think that's it. I have just overrun the time. Any questions? I don't know if you have time for that or not. We already discussed so many questions. Thank you all.
Thank you so much, Dinesh, Velhal. May I request Director QEA Cognizant? May I request co-founder Leap Infosys Systems, Mr. Sudhir Patil, and step-in conference chair to please felicitate Dinesh Velhal.
Thank you.